Greetings! This video will showcase our project for TCSS 450 mobile apps by Travis Holloway, Nicholas Mausel, and Addison Sims. The concept for this application was to recreate the classic Atari game Centipede, but in mobile form. The effort appealed to our group as it presented an interesting challenge and many avenues for learning. Along the way, we became familiar with the Android Studio features, like Surface View, Canvas, Drawing, and Threading. The first screen the user is greeted with on launching our app is the login screen. Here, the user will either log in with an existing login, or if this is their first time using the app, they can register a new account, with appropriate restraints on account name and passwords. Here we find the main menu of our app. The user has the choice of two options, start a game or view high scores. The user also has the choice to choose between 3 songs to determine what song will play during gameplay. Having made our choice, we will now start a new game. This is the classic Centipede gameplay. A centipede starts at the top of the screen and moves laterally. Meanwhile, the user can move their ship in an effort to direct a stream of bullets at the centipede. Between the protagonist and the antagonist are a field of mushrooms, which represent obstacles to both. If a centipede collides with a mushroom, it will reverse course and drop down a level. If a bullet does so, the mushroom will degrade and eventually it will be destroyed. If a centipede is hit by a bullet, it splits into new centipedes. The game ends when either all of the centipedes are destroyed or when one reaches the player area. At that point, the score is tallied and the user is returned to the main menu. The other option of the main menu is to view high scores. All high scores are stored in shared preferences where they are sorted by the highest score. Appended to each score is the date in which the score was recorded. This way, the user can see what their most successful game was and when that game occurred. While the end goal of our app was to have a playable game, the true learning experience for us as students came about when we decided halfway through development to implement the ECS programming architecture. What is ECS, you ask? Well, I'll share it with you through the Wikipedia. Entity Component Systems, or ECS, is an architectural pattern that is mostly used in game development. And ECS follows the composition over inheritance principle that allows greater flexibility in defining entities where every object in the game scene is an entity, i.e. enemies, bullets, vehicles, etc. Every entity consists of one or more components which add additional behavior or functionality. Our implementation was broken up into several parts. These several parts included systems, components, and an entity manager. Systems operated on collections of components. Entities were made of a collection of components. The entity manager stored the connections between the entities and components for later consumption by the system. We chose to implement this by having all objects in the game be a meta-entity. Each meta-entity then had a collection of shared components, like health, position, and movement, as well as unique components based on unique behavior, like the touch class for the player ship and the shoot class for bullets. In ECS, everything is an entity. However, when I mean everything is an entity, I do not mean that every class is an extension of an entity. In fact, an entity is just an integer. This integer is then mapped to a collection of components. Entities can have shared components like health or position, however, some may have unique components like shoot. Since all objects were an entity, we could easily add and remove components from any of them without having to develop new code for each entity type. An example might be that we could make centipedes shoot, or mushrooms movable, or even give the player ship multiple segments. All of this would be handled seamlessly by the systems that acted upon the components. Since a system need only concern itself with the components it was looking for, we had no need to consider what objects the system was acting upon. The touch system only cares about entities with a touch component, and so on. This was the major advantage that made us choose to undertake porting our code to the ECS architecture. Unfortunately, there is complexity in any programming architecture that requires the programmer to have a deep familiarity with the system in order to reap its benefits. It is this conundrum that eventually caused our code base to grow needlessly complex and difficult to maintain. Given enough time, and armed with the lessons we learned through the development process, we are excited about the possibilities that ECS provides. As it is, we have a somewhat underwhelming game experience, but a deeply interesting code base. We did not have time to develop a method of having different systems, subsystems, communicate with each other. This problem was recognized when we had to implement asynchronous events like collision. We would have solved this problem by using the observer pattern. This way, systems would be able to listen to other systems when those events occurred. We worked around this problem by making all of our events polled. In conclusion, there are no mistakes in learning. As a group, we feel like the last 11 weeks have been crucial to our development as programmers. We do wish that our app had the features that we had envisioned when we initially met to brainstorm it, but we are still very proud of our effort and the result. Thank you for watching our video.